Hello and welcome with something new again, something again interesting, something very much you'll be focused on because nowadays, you are going to face your exams. So I wish you all good luck, all my students who are watching this lecture, today's lecture. It's very informative for them because they are going to maybe they will have few questions from this lecture also. So it's better if they focus on all the video lectures which I have presented to them and which I've shared on my channel. So please do watch all those videos. That would be informative for you because I've been in touch with you since last 5 to 6 months, I think now, and all my lecture series are there. So you are supposed to focus on all the lectures which I previously uploaded on this YouTube channel and on your LMS system of University of Sindh. So I'm Professor Dr. Moina Akhtar Mughal from Dr.Mchem Institute of Chemistry, University of St. Jamshedpur, and I'm here again with something new, something interesting, something more knowledgeable for you to focus on. So today, I thought that I must share with you a new organic preparation, that is preparation of picric acid, which we also call it 2,4,6-trinitrophenol. So what is this picric acid actually is? So it has got a phenolic, of course, a phenolic compound, benzene ring that has got an OH group at the top, right? It is called phenol, simply. Now, what is phenol? We will discuss that in some other topic. But right now, we are just simply going to see what's going on, what this phenol is going to do. So we are going to sulfonate the phenol. In the first step, we are going to sulfonate it, right? Followed by or you can say after a series of more steps, after a heating process, a warm heating, after warming it, you're going to get, the ortho and para sulfonic acids, right? And that is the sulfonic group, that is SO3H group, is going to get itself attached to the ortho positions and, of course, the para positions of the ring, right? And then you are going to encounter another step, right? And what is that step? That is a step that needs to begin when you will lower down the temperature of your reaction mixture. Your reaction mixture's temperature was high. You will lower it down to that level to hit the temperature so that you can do the process of nitration. Now, what is nitration? I told you in a lot of my videos before that what is nitrations, right? You will add concentrated nitric, mixture of concentrated nitric and concentrated sulfuric acid, a nitrating mixture. We can also call it a nitrating mixture. So you will add this nitrating mixture to your reaction mixture and you will again warm it for a period of more time you will take in warming the reaction to progress, and then finally you are going to get your product, that is 2,4,6-trinitrophenol, which you call it picric acid, right? So now this nitro group, what it will do, that it will simply break from that nitric acid, and it will one oxygen will be less there and it will get itself attached to these 2, 4 and 6 positions, forming what do we call it, 2, 4, 6, and as there are 3 nitro groups there, so we will call it 2,4,6-trinitrophenol. This would be the name of this new compound which you are going to synthesize today, I'm going to teach you how to synthesize. I'm going to tell you how to prepare it, and I'm going to make you learn, right? So I thought that I must make you follow this experiment because you should know how to do it in the lab. So when we will meet in the lab, inshallah, hopefully we will do it there also. But let's start here now today. So now, as it's an synthetic process, right? So you'll be needing a lot of things. That is, for example, you'll be needing a measuring device from where you can weighing device where you are going to weigh your compound. Initially, you are going to take few grams of phenol, and then you are going to measure 1 ml of sulfuric acid, right? And that is how you are going to measure that 1 ml sulfuric acid. You will definitely need a measuring cylinder. So there are a lot of things which you are going to need initially, which I must must tell you how, because whenever you plan an experiment or a synthesis process you are about to start, you need to gather a few things on your desk. That is, of course, the measuring cylinders. If we'll start from the glassware, measuring cylinders, glass rods, beakers, of course a flask is needed. And what type of a flask? In this particular reaction you are going to need a round bottom flask or a flat bottom flask. Both are, I mean, appropriate for this type of a reaction. And then of course you will be needing funnels, different type of funnels to filter the compound, right? And you'll be needing a thermometer to maintain the temperature, to regulate the temperature. And you'll be needing, I mean, the clamps and the stand, of course, and the filter papers, and of course the acids, the chemicals you are going to need. Of course you'll be needing phenol, right, which is in the solid form. So you have to, I mean, put all these things organized on your desk before you are going to start your experiment. This is how this simply, any experimental, any synthetic process, it goes on, that you have to organize your laptop properly, and then you are going to start your experiment process, right? And of course, as this is an organic synthesis, as I mentioned it many times, that you need to perform this organic synthesis process either in a well ventilated place that is all open, or it is supposed to be, I mean, in a fume hood. Fume hood is recommended, right? You're supposed, and the other things that are supposed to, you are supposed to take care of are, of course, your masks, your goggles, which you are supposed to wear, the hand gloves, you are supposed to wear hand gloves, and of course the sanitizers. Nowadays the sanitizer is the most important thing, more even important than a perfume or a body spray. A sanitizer is supposed to be there always with you, right? So these are the things which you are supposed to, of course, you are going to get, you'll be needing them, right? And then of course, when you prepare a compound, when you synthesize a compound, the last step, when you got your product in the end, when you're happy, yes, you have your product. Now what is in the last point is that you are going to you have your product. Now that product, what do we call that product? The crude product. What do we call it? It's called a raw product, right? A crude and a raw product. So now that raw product is supposed to be purified. And what is the method of purification? Of course, you will recrystallize it. And what are the solvents that are always recommended for recrystallization? Mostly they are recommended, they are of course the ethanols and methanol. These are mostly used for, I mean, this processes, that is of course for the process of recrystallization. And what is recrystallization? I have explained it I think many times, that how this process goes on. You will simply take a minimum volume of the solvent and you will dissolve your compound in it, and if it's not getting dissolved at the room temperature, you will use some heat source, a light heat warming will be done, and then you will leave it there for some time to hit the room temperature. When it hits the room temperature, and if you find few crystals there, then you'll feel happy, yes, the crystals are forming there. But if and you will leave it there for some more time, and you will, for about half an hour, you just leave it there with, cover it up with some filter paper, a piece of a filter paper, and then leave it there for a while, and then see if there is any crop of crystals has started settling down at the bottom of the beaker or of the bottom of the whatever the flask you are using, right? And then you are going to filter off your product. This is the easiest way to recrystallize your product. That product, you will call it the most purer product, the most purest product. It's no more crude, it's no more raw, it's no more, without purification, it's the purified. It's the purified product you got in the end. So this was about, the whole process which you are going to encounter in any type of a synthesis you do in your organic chemistry practical lab, right? So today, let's start our experiment. I have prepared few slides for you people so that I can move on systematically with the experiment process, and you will be able to see it, how it will be done. And it is from your scheme. You can see it. You have been provided the scheme, and the scheme is for you people, right? And it's simply the same scheme which I have shown you in the beginning of this semester, how you're going to do this preparation. So let's start. Let's start the screen share. Okay, so there we are. Yes, so this is how to synthesize. I've made this beautiful slide for you. Just look at my handwriting, how beautiful it is. Okay, so there we are. How to synthesize picric acid, okay, or 2,4,6-trinitrophenol, same thing, but that is the IUPAC name and that is its common name. Fine. Okay, what is now picric acid? Picric acid comes from a Greek word, right, called picros. Picros, and it is found to be bitter in taste. Now, you are not supposed to taste it, but they are saying that this is, of course, bitter in taste, right, and can be used. Now you can, if someone asks you what could be the uses of this picric acid, you can tell at least 2 to 3 uses. But as a medical point of view, it is useful as a medical point of view, and of course it can be used as an explosive, and it can be used as a dye also, right? Fine. Now its preparation, what its preparation composed of, comprises of course, a number of steps. Okay, number one step, as I just told you, we are going to sulfonate now. Sulfonate it. Now here you can see sulfuric acid, H2SO4. Now I have not written concentrated its form. Of course, it's concentrated sulfuric acid. You are going to use it so that the process of sulfonation will go on. Right, so we'll sulfonate this phenol. We'll add some sulfuric acid to this phenol, and then undergo nitration. And then, of course, we will undergo this process, that is nitration. But in between the sulfonation and the nitration, what will happen? That when you will sulfonate your phenol, you are going to get the two products. What are those products? That is an ortho phenol sulfonic acid and paraphenol sulfonic acid. You are going to get these two products, right? Now, the sulfonic group will get itself attached to the ortho position and to the para positions of this ring, right? Now, after that, you will nitrate. You will go through the process of nitration finally. Okay. Now here I have written few indications. That is, phenol should be handled carefully. Yes, of course, it's a chemical. You're supposed to handle it carefully. But phenol is supposed to be kept airtight, right? That means that it should not be exposed to air. Otherwise, it will go oxidation. It will undergo oxidations. State will change. It will undergo oxidation and will turn into a liquid form. It is mostly it's in the solid form, so it gets into a liquid form, and it will turn its color. It will become a little darker in color, or more brownish, or like that. It will change its color. So do not expose it for a longer period of time, right? Okay, then now we'll get to the second slide. Okay, now let's see the process. I've written this process for you so that you can easily go through all the steps. Dissolve 0.5 gram of phenol in 1 ml concentrated sulfuric acid, right? We have taken very small amounts of the, chemical, so that, I mean, it's just the wastage. Otherwise, you just dispose it off somewhere. So it's better to use less quantity, and it's useful for everyone. It would be beneficial for everybody. Okay, so 0.5 gram of phenol is taken, and in 1 ml concentrated sulfuric acid in a flask. You can use a round bottom flask, which I just mentioned it earlier, by constant swirling of the flask, and when warm it on the water bath. Right now, you have a flask in your hand, and you will warm it on the water bath. Yes, for about 30 minutes. Now here they have written the period almost about 30 minutes. You have to warm it on the water bath. Now you have a bath filled up with water, and you will simply warm it, right? You will not boil it, you will warm it. There is a difference between boiling and there's a difference between warming. So you'll simply warm on the water bath for about 30 minutes. Now the reaction mixture, this reaction mixture that is inside your flask will turn dark brownish color due to sulfonation, as phenol forming ortho and para phenol sulfonic acids, right? Yes, of course, that process will go on, and as I have mentioned it earlier, that ortho and para positions will be occupied with this sulfonic group, right? This is happening here, as you can see here easily. Okay, now the temperature, you have to monitor one thing here. That is the temperature. That means you need to have a thermometer there in the reaction mixture, right? You have to insert a thermometer inside the reaction mixture, and the temperature should not exceed above 80 degrees Celsius, right? You have to keep an close eye on the thermometer, that it should not exceed, the temperature should not go above 80 degrees Celsius, right? Okay, now I have mentioned here what somebody because can ask you what could be the heating source, how we can, I mean, go on with the process on what even, I mean, what heating source we should take, we should adopt. Okay, you can, heating source could be a hot plate, an electronic hot plate, right? Or a water bath. You can use both. Both are preferable, right? Even a heating mantle is preferable as it is a round bottomed flask, so you can use a heating mantle also. Okay, but it has to be well regulated, right? The temperature is supposed to be regulated because you have to monitor the temperature. You have to see that the temperature should not go above 80 degrees Celsius. So that is the main point of keeping the temperature and keeping your eye fixed on the thermometer, right? So there we go. Okay, now next step, cool. We have, I mean, warmed the temperature and it was up below 80 degrees centigrade. Now the next step, cool you can see here, cool, and let the temperature lowers down to 6 degrees Celsius. Now they are saying that, now wait, put off your flask from that heating source and put it at one side of the table. You can put it at one side of, on the table, right? And let it hit the room temperature below the room temperature, right? The room temperature is not 6 degrees. Okay, so you have to lower down the temperature around 6 degrees Celsius, right? So now what we are doing this, so this is there is always a reason. So I have written the reason that just to ensure before doing the process of nitration, that means before adding nitric acid to it, you are supposed to lower down the temperature, because when you are again going to nitrate it, it's going to be an exothermic reaction. There is going to be an exothermic reaction, and we do not need any aggressive sort of a reaction. We need a controlled reaction. So for that, we need to lower down the temperature before we progress with our nitration. Okay. So before adding here, I've written nitric acid to it that could cause an exothermic reaction. So now add concentrated nitric acid, that is 2 ml, almost 2 ml, with shaking and for complete mixing, right? With the shaking, that means you can shake it like that, right? You will shake your flask like that, but of course you will add nitric acid. You have 2 mLs. Now you are not going to add, you have a measuring cylinder in which you have measured 2 ml nitric acid and you are going to drop it like this. No, never do that. Never do that. I have mentioned this thing to you again and again. Many times I have explained this thing that always you do a dropwise manner. A drop and then shake. A drop it and again shake. Drop and shake. And I even see the changes. Observe the changes that are, if you can observe some changes there when you are doing this mixture of acids, right? Okay. So now we are at that step that you have added 2 ml of this nitric acid, concentrated nitric acid to your reaction mixture with shaking for complete mixing. Yes, we have, we are observing, we are keeping these things in your mind. Okay, now what happens after that? A vigorous reaction starts. Yes, this was expected, of course, because we are nitrating it. And red fumes are evolved. And these red fumes, now what will happen when you will do that? You will start seeing, you'll start observing escaping of fumes. And what are those fumes? These are of nitrogen dioxide. Nitrogen dioxide is very toxic. It's very, it's very pungent. It's toxic to your health. You're not supposed to inhale it or anything like that. You have to be away. You have just keep yourself a little bit away when you are, observing the fumes that are coming. Though you are doing it in a fume mode, but just get yourself away, a little bit away from the fume hood even, and let those fumes escape. And they are orangish, deep orangish in color, and they are very beautiful to observe. If you are safer, if you are in the safer zone, then they are very beautiful to see how they are escaping from that flask, right? So that is nitrogen dioxide, right? So their red fumes are evolved, and these red fumes are of nitrogen dioxide and are toxic and are pungent. Okay, now what will you do? You will now wait. You will let all these orangish fumes escape, right? And after some time, you will see that there are no fumes. It's almost, the fumes are all gone. The flask is almost all clear, right? Now you're going to heat this reaction mixture again on the on a water bath for about 1 hour, right? Again, you are going to heat it for about 1 hour. The 1 hour heating period is required, right? So okay, so the third slide, let's see this third slide. This experiment should be performed with a fume hood. Yes, I have explained this thing that you have to, you have to see that whether your yes, you have to be very patient when you are, seeing this. Yes, of course, you're doing this within the fume hood, and you are watching that. Yes, of course, the vapors were escaping, and you can see here the orangish fumes here. I have drawn this beautiful drawing for you. This is the boiling water, water boiling, and this is the fumes that are emerging out. They are escaping, right? These are all nitrogen dioxide fumes. Now, for the period of 1 hour, you will keep continuing this heating period, and after 1 hour, you are going to get orangish, goldenish, beautiful precipitates of CO246-trinitrophenol, right? And these are, you have written here also, golden crystals of picric acid will appear after, over here, right? Fine. Now you will recrystallize your product, this crude product, and you will end up with your pale yellow precipitates of your picric acid. This is I've written here also, that is finally pale yellow crystals will recover, you will record the melting point and everything. Fine. Okay. So that was it, and then let's jump to the next slide. I have prepared few slides so that you will be able to, follow what was even. I'll share it again in a while. Okay, so now what is the background of this reaction? A little knowledge about that also. Okay, when OH group is attached to the benzene ring, and initially you have seen a benzene ring with the OH group. Okay, the compound is called phenol. We call it phenol. Fine. Okay, the nitro group get itself attached to the 2, 4, and 6 positions of the benzene ring. It will get itself attached to these 3 positions. That is 2, 4, and 6. And that's why we call it trinitrophenol. There are 3 nitro groups, so they are attached at the 2, 4, and 6 positions of the ring. So we call it trinitrophenol. Okay, nitro group is an electron withdrawing group. Yes, we know it. It's a strong electron withdrawing group. Its acidic character, it resembles, or it is similar to what, of course, the other 2 acids, strong acids, that is HCl, hydrochloric acid, and sulfuric acid. Okay, so phenols have this OH group that is very active in its nature. Yes, it is activating as electrons are dense and ortho and para positions. Now, if you will simply see at the resonating structures, you will see that particularly at the ortho and para positions, you will see the density of electrons is extremely, it's at its extreme level, right? Whereas at the other position, it's not. So electrons are dense at ortho and para positions, which I have just written over here, right? Mostly. And if you look at the resonating structure of phenol, you will see that it will direct the incoming electrophilic groups to ortho and para positions mostly. It directs the incoming electrophilic groups to these ortho and para positions, right? That's why the substituents as ortho and para substituents, what will happen that the groups will get themselves attached to the ortho and para positions and as substituents. You will mostly see this. So because of course it's electron withdrawing group, right? Nitro group. Okay, so let's jump to the last slide. So this was a reaction pathway of our picric acid. Today's picric acid, that is 2,4,6 trinitrophenol, right? So I have drawn this amazing drawing. Though it's not amazing, it's a little bit difficult to understand, but I have marked the numbers of the steps. That is number 1, then 2, then 3, then 4, then 5, then of course 6, then 7, 8, 9, and then 10. That means there are 10 steps of this reaction to go on, right? It will go complete within this, within 10 steps it will take to complete. Fine. Okay, the initial step, let's get to the first step. That is, of course, the 0.5 gram of phenol was dissolved, right, in 1 ml of sulfuric acid in the round bottom flask. Initially, we took the round bottom flask, right? This is the round bottom flask. Now here you can see the red color is, of course, phenol, and this bluish color is, it's just the colors. I have chosen because I don't have that much, choice of markers with me. So this is the colors which I have just suggested. I had at that time. So that's it. I marked it, phenol and sulfuric acid. Now we have this reaction mixture in our flask. Okay, now we'll arrange a water. This is a small assembly. You can see a burner. This is a burner with a red flame, right? This is a wire gauze, and over that wire gauze, this is a water bath, right? And a water bath has got this reaction mixtures containing flask. Our flask, this is the same flask, right? Now we will warm and shake it for about 30 minutes. You with the help of a pair of tongs, or you can use any other thing to ensure it's shaking, right? And this warming will continue for the period of 30 minutes, right? Okay, after that, number 4, cool before nitrating. Add 2 ml nitric acid. Yes, now as I've mentioned that you have to kept it aside and for some time before nitrating it. So this is the same thing I have written here. I've shown here that you have to keep it aside for some time so that you before doing the nitration. Okay, so this is the same flask, right? And you can even use ice bath for cooling it down to hit the temperature around 6 degrees Celsius, right? Then you will add 2 ml of nitric acid, right? And when you add those 2 ml, as I've mentioned it, that drop-wise you are going to add that 2 ml portion of nitric acid. You are going to observe a vigorous reaction will start, and you can see here the red fumes, the orangish fumes, they are just emerging, they are escaping from this flask, and these are all of nitrogen dioxide, red fumes, right? And they are evolving, they are escaping from the flask. So you will let that happen, right? And you will wait for some time, let the reaction, this is a vigorous reaction, goes on. So you just view it from some, a little bit distant, right? Keep yourself a little bit distant and then just let it cease, let it stop for a while, okay? When it just ceases and when it stops, okay, they are all evolved. You will see your reaction mixture is now smooth. It has settled down. There are no fumes. There is nothing, because this is all you can see an exothermic reaction. It goes on, right? So after that, the reaction subsided, what you are going to do, you are going to again arrange an assembly of a boiling water, right? You will arrange a boiling water bath, right? You will need a water bath, you will boil it. You will put your flask inside it, the same red flask, you will keep it inside this, and you will heat it for the period of 1 hour. These fumes are of water vapors, right? These blue fumes I have marked here are of boiling water. These are nothing else except water, because I just mentioned that I didn't have the choice to use any other colors. So this is simply the steam that is coming out, the water, right? The water is boiling. So you have to heat it for a period of 1 hour, and after 1 hour you will again take it out. You will wait, and you will keep it at one side, and you will let it reach hit the room temperature, and then you will cool the flask in some ice containing ice bath, right? And or you can use another method. You can use 20 ml of ice cold water. You can add into it, and after some time, you will see the crystals of picric acid that are forming at the bottom of your container, that is your flask. You will see fine crystals or powderish crystals of orangish pale crystals of picric acid will start forming, right? at the bottom of the flask. Okay, at that point you will filter off your compound as you have done before by using a simple filtration, normal filtration you can use, simply you will filter it off, and or use a Buchner funnel, and it's better to use a Buchner funnel because that's a suction filtration that will, I mean, give you a more beautiful product. In a few seconds you will get your product. So I mean, that's the best way if you have the Buchner funnel. Otherwise, do the ordinary filtration. You can do that also. And you will get your beautiful crystals of picric acid. Now, the next step is, of course, you have the crude product. As I mentioned it earlier, it's a crude product. The crude products needs to be recrystallized so that you will recrystallize. Now, this is the, I have shown the crystals with the red mark, where the impure crystals which you got in the end. And then after the recrystallized, of course, you have this one. This is the recrystallized product. This is the 10th step of your reaction, and this is the recrystallized product. So after I mean, going through the number of steps that is starting from 1 to 10, here that is number 1, 2, then 3, right? Then of course number 4, then number 5th, then number 6, then number 7th, then number 8, then we up jump to number 9, and then finally 10th. You got your product, you got your picric acid, you got your 2,4,6-nitrophenol, right? So this was the interesting reaction pathway of how you got your product, because we are right now, we are not in the, I mean, lab. So there was, I mean, difficult for me to explain to you on the by using any other virtual means. So this, I thought that I should draw it with my own hand, and I should draw them for you so that you can easily because these all things are in your mind. You know how the organic chemistry lab looks like, how you're going to use. I mean, you are mature students. You know what is a round bottom flask, how does it look like. So you can memorize all these things, and these things can, I mean, gather in your mind, and you can easily memorize the reaction mechanism, how it goes on. So this is how the reaction pathway of picric acid, it goes on. Sorry. So this was how you have prepared today 2,4,6-nitrophenol this, and I hope you have understood all the steps nicely, because this experiment was I mean, very much nicely described in your scheme. Also, you can see this paper also that has got this, I mean, this note and this scheme also, and you can see how they have I mean, performed the experiment. Though I have not followed this step or these steps all, but I have taken few steps from it. Yes, they have written that you should calculate the after recording. You should, first of all, when you have the recrystallized product, keep this thing in your mind that you have to record the. It's better to record the melting point before the recrystallization process and after the recrystallization process. There's always a difference, right? When you have the impure product, it has got other melting point, and when you have a purer product, a more product, a recrystallized product, you have a different melting point. So it's better if you if you record your melting point before and after the recrystallization process, and you note it down, and you should show it to your instructor at that time, that this is the difference between the two. If you find the difference, you just let your instructor know that you got that difference, right? You are intelligent enough to find out the difference between a crystallized product and a product that is not recrystallized, right? After that, when you have that product, you are now there to record them. I mean, to use your compound for any other processes, right? You can, I mean, after you have synthesized the compound, now you can confirm the formation of your compound by other means also. That is the CHN analysis. You can do the CHN, carbon, hydrogen, nitrogen analysis of your compound. You can see the percentages, how much carbon is there, how much of hydrogen is there, how much of nitrogen and oxygen is there. You can find out all these, or sulfur. These are all CHNS. Actually, it is called CHNS, and even oxygen is also there. So you can find out the percentages of these of these elements there in your compound, how much of that you will do it in a theoretical way, and then you will send your samples to the place from where they will analyze it, and then they'll send it back to the percentages. They will do it, And then the two values should match together, the found values and the values you sent there, right? They should not be, I mean, having a lot of difference between them, right? If you have calculated carbon as 68% of carbon in your compound, then it should, and turned out to be 67.5, then yes, it's matching, right? So it's just like that, it has to be very near. After going through CHN analysis, the next step is, of course, the FTIR of your compound, right? Your synthesized compound needs to be, I mean, you need to find out that whether the function groups you are looking for, you have prepared, are there or not. So you are going to run your experiment, your compound on FTIR instrument, right? That is Fourier transform infrared spectrophotometer. It will tell you about, it will give you the peaks of all those compounds, of all those functional groups that are present in your prepared compound, because now you know the name of your compound, 2,4,6-tri-nitrophenol, right? So then there are peaks of all those functional groups that are that are present in your compound. So it will show the peaks in the FTIR graph, right? In wave numbers, they will simply show you all the graphs, right? So in that sense, you will do its characterization. These are all the characterization steps, that whether your compound, the compound you are looking for, you have prepared in the lab, is actually been formed or not, right? So these are the initial steps. Then you will do the proton NMR of your synthesized compound, right? It will also tell you, and then of course you will go through the SEM analysis, right? The scanning electron microscopy. It will tell you about the, I mean, everything about the morphology of the compound, right? Then you can do its XRD analysis, right? And then there are thermogravimetric analysis. You can also do TG of your compound, that is whether it's heat resistant or not, right? And of course the XRD, it will tell you whether it has got, I mean, what type of crystal structure it has. If it's not an amorphous compound, if it's a crystalline compound, you can run it on XRD instrument, and then you will be able to find out what type of a crystal, orthorhombic or monoclinic, what type of a crystal structure it has, right? So I mean, this characterization is vast. It's very vast. And you can do the viscosity also. You can check the viscosity of your organic compound, synthesized organic compound also, that what would be the viscosity of your or in the prepared compound, right? You can calculate all the viscometric types, right? That is, you can use the Oswald viscometer. You can make the solution of your compound, and you can run your compound in the Oswald viscometer. You can use it, and you can record different type of viscosities. That is reduced viscosity, intrinsic viscosity, inherent viscosity, and of course a number of other. And then you can calculate the thermodynamic parameters also, delta HV, delta GV, right, and delta SV, that is entropy, Gibbs free energy. So there are a lot of things you can do in the characterization when you are characterizing your compound. Synthesis was the first part which you have done, which you are assigned right now, right? In part 3 level. At part 3 level, you have to BS part 3 level. You have to, at the BS part 2 level, you have to, I mean, you should know how to synthesize your compound in this way, right? And then how to, I mean, characterize your compound, and whether the compound you have prepared, whether the compound you have synthesized is actually, I mean, the compound it is supposed to be, right? And through these characterization techniques, these all confirm the structure of your compound. Okay, it confirms you that yes, you have prepared the correct compound. Okay, so this was all about 2,4,6-tri-nitrophenol compound, and that is called the Picric acid. And I hope you will find my lecture interesting. You will learn a lot of things from this lecture. You will learn how to prepare it in the laboratory, how to do the diagrammatic pathway. You have seen all the diagrams, the diagrammatic pathway I have drawn for you people. So sorry. So you will come to know all, I mean, these things, and you can rememorize them. You just learn them, and you just, because in the exams, anything can be asked from you, and anyone can ask you anything. Now you have a full detail of this experiment. Now calculate you have the compound in the end. You have the product you got in the end, right? The recrystallized product. Just weigh it on the weighing balance. This is your practical yield, right? This is your practical yield. And now you will calculate the theoretical yield with the help of the starting materials molecular weight and the ending products molecular weight, right? Product and the starting materials molecular weight. You will do the calculation and you will get the theoretical yield, and you will put in the formula for calculating the percentage yield of your compound, right? In this way you will get the percentage yield of your compound, and you will be able to, you will be able to tell your instructor, your teacher, that yes, this is the percentage of your compound. You have synthesized your compound, and this is the percentage yield of your compound. So I hope we'll meet next time with something new, something more interesting, something more informative, and something more, attention gaining, so that you will be more focused on my lecture. You will gain something from me, you will gain something from my knowledge, because I'm trying my level best to deliver whatever I can to you people, right? Whoever is interested in chemistry, whoever is not at all interested in chemistry, they will naturally be focused on the lecture or the instructor who is giving them so much of the knowledge in this, this pandemic situation, right? So hope to see you again. Bye bye, and good luck. Take care of yourself and good luck.